All right, the first one says 5x minus 1 is less than 1, or 3x minus 2 does not equal 5. And so you're just going to solve these individually. We're going to add that 1 to both sides. Let's do a color you can see there. Add that 1 to both sides. We have 5x is less than 2, and then divide by 5. And we get x is less than 2/5. Or we're going to do the other piece. So we're going to, all right, so then we're going to add that 2 to both sides here. And we're going to have 3x is not equal to 7. And then our last step here is to divide by the 3. So we have x does not equal 7/3, all right? This is an OR problem. So if I were to graph this left one, x is less than 2/5. 2/5 is about right here. So less than 2/5 is going to be open circle and everything that way. Does not equal 7/3. Well, 7/3 is like 2 1/3. So we're like right here. Does not equal is just an open circle and everything both directions. This is an OR problem. So it means I'm going to use the one that encompasses the most numbers. And so the answer to this is just going to be that x does not equal 7/3. Because if it doesn't equal 7/3 but equals everything else on the number line, that includes everything that's less than 2/5. I've already included that with that statement. So when I graph it, I can graph just this part because it's going to include all of this. Does not equal. And by graphing the does not equal, I've already graphed the less than 2/5. It includes that as well. And so when you graph it, you can just graph this piece of it because that takes care of all of it. All right, so for this one, I have 5/7 x plus 1/2 is less than 2. And is this or and? It's or, yeah. So for and, a lot of people do that. That looks almost like an A. So that's and. That's and. That is or. All right, so or, I have the 3/4 x minus 1/5 is less than or equal to 1/10. I can take this left-hand side and I can multiply by my common denominator, and I can do this right-hand side and multiply by my common denominator, right? So what's common between 7 and 2? Yeah, so I'm just going to take 14 and I'm going to multiply everything by 14. All right? And so if I do that, this is going to cancel. 2 times 5 is 10x. Here, those cancel, and I get a 7 is less than 28. Does that make our lives a little bit easier? Yes, it does. All right, and so then I can continue by just subtracting my 7. I'm going to get 21. Still going to give me a fraction, but at least it's one I can deal with. And then what's my last step here? Divide by 10. Yep. So right here, I'm going to get x is less than 21/10 or 2 1/10, right? So that is going to be just past my 2, closed circle, and everything less, right? So far, so good? Mm-hmm. All right, let's look at the next one. What's my common denominator between 4, 5, and 10? If you don't know, take your 10 and just take your multiples, 10, 20, 30, 40. So what's the lowest one that they all go into? All right. So far, so good? Mm-hmm. All right, now let's look at these graphs. For this one, I have the open circle and everything to the left. For this one, I have what? Closed circle, right? At 2/5. 2/5 is like here. And also everything to the left. This is and or. So it's actually going to be the one that covers the most numbers. So all I have to do is worry about this one. That covers the numbers for this one, and it covers the numbers for that one, right? With or, it's all the numbers, not just where they cross over. If it had been and, I would only want where they start crossing over, okay? But since I want the or, I'm going to just worry about this one. So it's going to be an open circle here and everything to the left. That's going to include this red line and that line. If it had been and, I would have started here at this line, only where they started crossing. Because it's or, I can go all the way back to here. You can put it on my desk. All right? So you can actually just, your answers actually can just be this piece of it right here. Because that includes the other piece as well. Pay attention to the ors. Ors means it's all of them and is only where they start crossing over. Only where they start crossing over. And the last one was also an or. They gave us all or problems, by the way. Quickly, we got to move on. Write it down quickly. Because we have 2 lessons to do today. We're finishing the chapter. Okay. All right. This one would probably look like a gem compared to the other ones. All right. So this last one must have been a breeze after all those fractions. Subtract 1. We have 3x is greater than or equal to 5. They still give you a fraction, but at least it's at the very end. You get x is greater than or equal to 5/3. Over here, we have to distribute. So we have 36 minus 9x is less than or equal to 15. Subtract your 36. Make sure you bring down a negative 9x is less than or equal to negative 21, right? And then divide by a negative 9. What happens when I divide by a negative 9? What happens here? Yeah, greater than or equal to. Does anything go into 21 and into 9? Yeah, 3. So it's going to be a positive 7/3. Positive 7/3. Again, this is or. So if I were to graph these, 5/3, that's 1 2/3, right? 1 2/3, so that's about right here. Closed circle and everything bigger. And then 7/3, that's 2 1/3, so that's about right here and everything bigger. This is an or, so I want the one that includes the most numbers. Which one am I going to do? The red line or the purple line? Yeah, the red one. That includes the most numbers. The one, if it is and, that would have been just where they cross over, fewer numbers. Recall that the absolute value can be thought of as its distance from the origin, so how far away from 0 you are. So absolute value of 6 is 6 units away from 0, and absolute value of negative 6 is also 6 units away from 0. That is what absolute value means. The actual definition is the absolute value of a number x is as follows. The absolute value of x, if x is greater than or equal to 0, that's just x. If x is less than or 0, it's negative x. It's the opposite. All right, so pretty much it's always going to be positive. The absolute value is always going to be positive. So then how does this relate to equations? Look at the first example on page 170. The first example on page 170. They want us to solve this equation. It is an absolute value equation. So first, let's think about what this means. I have an absolute value here, and it equals 11. The absolute value equals 11. Well, that tells me that what is inside the 2x minus 5, that could equal 11. Absolute value of 11 equals 11. So 2x plus 5 could equal 11, right? However, 2x plus 5 could also equal negative 11, right? If the 2x plus 5 is negative 11, I still have the absolute value of that equals 11. That's still true. And so anytime I have an absolute value equation, I am going to solve the inside for what they have given me, and I'm going to solve the inside for the negative of what they have given me, because both will work because it's absolute value. And so I set up 2 different equations. I say, what's inside 2x plus 5 without the absolute value? 2x plus 5 could equal 11. Okay? It could equal 11. Or 2x plus 5 could also equal negative 11. Both of those are true, because if I were to get 11 and plug it in, the absolute value of 11 is 11. If I were to get Negative 11, the absolute value of negative 11 is also 11. And so I'm taking what's inside and I'm setting up two different equations here, okay? And once I have this, I just solve. I solve them individually. So I'm going to subtract my 5. I will get 2x. 11 minus 5 gives me 6. Divide by 2. X equals 3. That's one of my answers. You will always have two answers unless it equals 0. So on the right-hand side, I'm going to subtract 5. I will have 2x. What's negative 11 minus 5? Negative 16. Negative 16. Right. And so I get x equals negative 8. So these are my two answers. X could either be 3 or negative 8. And so I'm going to check it. I'm going to go back and check my work by plugging it in. So if I said absolute value of 2 times 3 plus 5 equals 11. 2 times 3 is 6. Absolute value of 11 equals 11. Yes, that is true. If I plug in my negative 8, 2 times negative 8 plus 5 equals 11. Negative 16 plus 5. And then I have negative, absolute value of negative 11 equals 11. That is also true. And so you can see for absolute value equations, you always have two answers. The only time you won't have two answers is if your absolute value equals 0, because there is no positive or negative 0. And so you only have one answer. But for every other type, you will have two answers here if it equals a positive number. So the first thing they tell you to do is they simplify within the absolute value. So if there's anything you can do inside the absolute value to simplify it, do that. Isolate the absolute value. That means get everything off of one side of an equation until you have the absolute value piece completely by itself. Use the definition to write two equations. So once you have simplified the inside of the absolute value and then gotten the absolute value completely by itself, you are going to set up two equations, solve the equations, and then you can check them. So let's look at this next one. What is the difference? Well, first of all, I have multiple things within this absolute value. One set of them being like terms, okay? That's one difference. I also have something on the outside. All right, so according to these steps, I'm going to simplify this inside, and then I'm going to move this 5 out of the way because I want the absolute value by itself, and then I'm going to set up two equations, okay? So you want to simplify first and then set up your two equations. And so if I look at this one, I have a 2y and a negative 5y. So I will leave this piece alone. I have 5 plus. I can combine the 2y and the negative 5y because they are like terms. That gives me, what's 2 and negative 5? Negative 3y, and then I just have the plus 4 because it can't combine with anything. That equals 21. The next thing I need to do once I've simplified it is I need to get rid of this 5. I need the absolute value by itself. So how do I get rid of that 5? Subtract. So I'm going to subtract my 5 over. Then I have the absolute value of negative 3y plus 4 equals 16. Now I have something that looks just like example 1. I have an absolute value all by itself equals some positive number. And once I have that, then I can set up two equations. So I'm going to take what is inside negative 3y plus 4 and set it equal to 16. Or what's inside negative 3y plus 4 could equal negative 16. So once I have simplified my absolute value and gotten it by itself, I'm going to set up two equations. What's inside can equal 16. What's inside can equal negative 16. Okay? And then we're just going to solve. What's my first step here? What do I need to do first to solve this left one? Yes, subtract my 4. Okay? So subtract your 4s, you get negative 3y. What is 16 minus 4? 12. And then my last step on this side is to what? Divide by negative 3. So I have negative 3. Y equals negative 4. Or, I'm going to do the same steps on the other side. Subtract 4, but now I have negative 16 minus 4. What is negative 16 minus 4? Negative 20. So then I'm going to divide both sides by negative 3, and I will get that y could also equal 20 thirds. I cannot reduce 20 thirds, so I'm going to leave that alone. And I would have my two answers, negative 4 or 20 thirds. Be careful with equations like absolute value of x plus 5 equals negative 3. For this equation, it says the absolute value of x plus 5, the absolute value is all by itself, equals negative 3. When does an absolute value of something equal negative 3? Never, right? So if I looked at this one, you may be tempted to say, well, x plus 3 equals negative 3 and x plus 3 equals positive 3. No, it's not going to work if you set it up. This is empty set. This would be no real numbers. There are no numbers that will ever be plugged into this where the absolute value of that number equals negative 3. If I got positive 3 in here, that's not true. The absolute value of positive 3 is not negative 3. If I got negative 3 in here, that's also not true. The absolute value of negative 3 does not equal negative 3. And so if you get one where your absolute value is by itself on one side of the equation, and they're telling you that that absolute value equals a negative number, that will never be true, and your answer will be the empty set. Meaning there are no numbers that answer that question to make a true statement. And point out, you could see something like this. Absolute value of x plus 5 minus 8 equals negative 3. Well, my absolute value is not by itself yet. So I can't make that judgment call until the absolute value is by itself. Because once I add that 8 over, I would get absolute value of x plus 5 equals 5. And that could be true, right? I can set that one up. So make that decision once your absolute value is all by itself. When the absolute value is all by itself, it cannot equal a negative number. What's inside can equal,